Okay, so this is the example that we tried to do last time on SAP 2000. Let's try today to do it on ETABS and see how fast or slow the process will be from SAP 2000 to ETABS. Actually, most of the analysis softwares are the same. Like if you're working on SAP, ETABS, SAFE, MyDAS, there's lots of analysis software, and actually there's a new one that is very good. It's called RFIM. So all these softwares have the same concept. You need to define materials, you need to define sections, you need to draw geometry, and you just need to figure out how you can do this on the software. But you need to know the steps, because you cannot run a model without knowing what materials that you are using and what geometry that you have and what cross sections that you draw, because this will be completely different when in terms of straining actions. Like if you draw with a steel cross section, like you can assume that you are drawing a concrete cross section 25 by 70 centimeters. If you mess up with the materials and you use steel material rather than concrete, it will be very, very stiff cross section, and we will not have any deformation. Okay, all right. So let's see how we can do this on ETABS, and let's see how much similarities between ETABS and SAP 2000. So pretty the same. Once you open ETABS, you will hit File, New Model, and it will ask you one quick question: what is standards that you would like to use? So I would like to use metric standards, so I will use metrics, not US standards. However, you can use other standard. I mean, like metric, when I draw elements, I need it to be kilonewton meter. I don't need right now to do it pound, inch, or feet, okay? But you can keep the design standards, like what design standards that you want to see, the IS, the AISC, the ACI for design of concrete. So you can keep, yeah. Yeah, I'm recording. Yeah, no problem. Yeah, good for checking. Yeah. So let me make sure. Yeah, your screen are shared, and I believe it's recorded. If I say stop recording, we'll stop. Yeah. So here, I'm only caring right now in this course about the analysis. I don't care about the design because this is an analysis course. So I will make it metric so I can, since I have all my units here are in meters and kilonewtons, and I will say okay. Once I hit okay, it will start and will ask you same questions like SAP 2000. What is the grids that you have in X and Y directions? And what is the spacing and everything? But in different interface. So here it asks, do you have a uniform grid or you want to customize the grid and edit the grid manually from verse? Actually, what I would do, I customize the grids and make them one by one because they are different. But what if you put anything, like you put the number of grids is like 9 in X and you have 10 in Y and the spacing are 7 and 7. So, and then you hit okay, that's fine. You can actually, after you've done that, you can change it, okay? Second thing, it asks because ETABS is specialized in the analysis and design of tall buildings. So if you are designing a tall building, ETABS is one of the best options that has been used to design most of the tall buildings in the world. Like Burj Khalifa, many of the tall buildings in the world are designed by ETABS. So, and that's why it asks about the stories. So how many stories do you have? How about I will go with 1 and the total, the typical story height is 3 and the bottom story height is 3. However, most of the tall buildings, the first story is a podium that has like much higher elevation, like maybe 10 meters or something. And the typical stories start to be like 3 meters because you have a hallway down there, you have a hotel, you have an open area. So basically it's much bigger. Sorry, it's much taller. And right now I will go with 1 story and typical story height is 3 meters and 3 meters. So right now I only make grid only. So this is my option. If you make it blank, so you will start your model without any grids. It will be a blank page. And here, if you know from this, what is the system that you are going to use for the slab? Is it a flat slab system? Is it a flat slab with a perimeter beam? Is it going to be a waffle slab? So all these different systems, but right now I don't know. Like right now I don't know what system that I'm going to use. I'm doing preliminary analysis to know what is the bending moments are, and based on this, I can decide what slab system that I should use that can best fit these internal forces. Okay, so I will go with grid only. And now you will have two windows. One of them will be like 2D and the other one will be 3D, like what we have in SAP 2000. So this is the 2D, and it tells you you are at story 1, and it's at elevation 3 meter, and this is your grids. Since I have only one story, I have one at the bottom and one at 3 meter. You can actually go with this arrow to move down by stories. So this is the base at 0 meter, and this is story 1. Here it tells you story 1 at B equal 3 meter. So right now, I know that the grids are not well aligned with what I have on AutoCAD, so I need to modify them. So you right click on the window and you will add and modify grid. Here, the grid in the vertical direction is separated from the XY direction. So the vertical direction is called the stories here, story 1 and story 2. So if you want to add more grids at each story, you modify and show story data, and then you keep add some stories. And here you can quick add story, like you can quick add, so it will add story 1, story 2. This is for stories. So what if you want to change the XY grids first? So you will go to the grid system G1 and modify G1. It will be much bigger screen. You will have X grid data on the left and Y grid data on the right. As you remember from the last time, we have in the X, we have 0, 3, 7, 12, 14.5, 17, 22, 26, and 29. This is the grids that we have from last time. So let's put them here in ETABS 0, 3, 7, 12, 14.5, 17, 22, 26, and 29. This is the X grid data. How about Y? We have 0 and we have 3, and then 7, 12, 1 meter will be 13, 16, 17, 22, 26, 29. So we will have here 0, 3, 7, 15, oh, sorry, 7, let's go back, 0, 7, yeah, 12, and then for 12 and then 13. And then the core will be 16, 17, 22, 26, and 29. So this is the grids that we have from last time. You just go to your AutoCAD and identify where is the grid's location. And then once you are done, you will say OK. And then OK, so you will find your grids are adjusted. So right now, my grids is ready to build the geometry. But before I build the geometry, I need to do some definition for the materials and the cross sections. So here, I will go to define, same thing. You will find the define and material properties, and you will find some more materials are defined, more steel materials. So you will have the 4,000 pound per square inch concrete. You can modify it. Actually, you can add a copy, and then you can call it concrete 40. And then you can adjust the weight per unit volume, the modulus of elasticity, and the Poisson ratio. Usual Poisson ratio is not a change it. The one that you can change the modulus of elasticity based on the strength of your concrete or the grade of your concrete. And then you will say, okay, so then you are supposed to find your material here, concrete 40. And then I will say, okay, this is for the definition of the material. You can define and use steel material. So you can actually go here and modify and see what is steel material that you have. Then the second thing is the definition of the cross section. And here is much convenient because it separates the wall system from the slab system. Because in SAB, we define a wall as a shell, same as the slab. But here, it gives you that the wall is different from the slab. Actually, they are the same, but here it just like give them different designation so that we can use them properly. Okay, so let's define frame section first. Here you will find lots of frame sections has been introduced, like lots of steel sections, white flange sections, and you will find a concrete beam section. So I can add a copy of this, or I can actually add new property. You can add new property and say concrete, and you can change the material to concrete 40, and you can name this beam 25, 70 centimeter, and I make sure that I change this from like we can keep it millimeters, so you'll have 700 and 250 millimeters. Materials is defined, and then I say okay. I'll find my cross section here, beam 25 by 70. You can add new property, or you can actually take a copy of the concrete column here. You have a concrete column. I can actually add a copy of this, and I name it column 50 by 50 centimeter. And I will make the material concrete 40, and it will be 500 millimeters by 500 millimeters, and I will say okay. And I add copy of this, and I make column 25 by 70 centimeter, and it will be 700 to 50 millimeter, and I will say okay. I defined all the frames across section. I will say okay. What I didn't do here, do you guys remember when I defined the section called wall dummy, so that I can select this section and extrude this section to be a wall? I don't have to do this because actually you already have a wall section. You can define it. You'll find it out. If you want to change the units from millimeter when we define the section, you can actually go to units and check what is the units that you can define. So you'll find here that the length, you'll have something in meters, something in millimeters. So you can make these units uniform. Like you can actually click on units and make it consistent units, and all the lenses will be in meters. So anything that you will find next, it will be in meter. Even the cross section that we already defined, if we went back to the frame sections and we go to beam 25 by 70 centimeters and I say modify, you will find it was transformed from 700 millimeter to 0.7 meter. Okay, so I defined the frame section. The next thing is I want to define the slab sections. So I have a slab here, so I will say modify, or I add a copy. I name it slab 25 centimeter, and I will make this 0.25. Here, actually, it's much better. It asks you what kind of a slab. Is it slab, or is it a drop panel in a flat slab, or is it a stiff element, or it's a ribbed slab, or waffle slab, or mat, like a raft foundation, or a footing. So you have all these definitions. If you hit waffle slab, it will ask you what is the waffle slab characteristics. What is the distance between the ribs in X direction, the ribs in Y direction, the depths of the ribs, everything about this system. But let's go with general flat slab that has thickness 0.25 centimeter. And then I will say, okay, I have my slab here. I will say, okay. The second thing, I need to define wall sections. I add a copy and I will name this wall 30 centimeter. And I will make the material concrete 40. And I make sure it's a shell thin. And I change the thickness to be 0.3 meter. And concrete 40 the material, shell thin the modeling type, thickness. And I will go very quick to slab section and make sure that I made the material concrete 40. Even concrete 40 is the same as 4,000, but make sure that you are consistent with your project to use the same material. Maybe it's different. Okay, so right now I did all the definition of the materials and sections. Second thing is I need to define the load patterns. Same thing, you will find load patterns, click on load patterns, you will find dead and live already defined. And dead has the on-weight inside, so let's define flooring. And flooring, you can keep it dead or super dead. Both of them are the same, and just like make sure that it doesn't have the self weight. And I add new load, and I will say, okay, right now I define the load pattern. You guys see any difference between SAB and ETABS right now? There's no difference. Same definition, same everything. So let's see what is different. Right now, let's draw the geometry. So drawing the geometry, I will start with beams. So you will find frame elements here, or you can go to draw and you will find draw beam or column, and then you will draw beam or column here. So what I'm going to do, I'm going to click on this, and here it will open, in SAP 2000, open a separate box, but the box here is going down, the properties that you will be drawing. So I will go to property and I will change the cross section here because there's lots of cross section, and make it beam 25 by 70 centimeter. Okay, so I make sure that I have the beam section right, and I go here, draw my first beam, second beam, third beam, and then I escape. And actually, we have another beam here. Okay, so I draw all the beams. So how about the columns? If you guys remember last time, we choose joints and we assign restraints, right? But what we can do here, we can draw columns directly. You will find something like I section. It's called draw quick draw columns. If you click on quick draw columns, I know, can you see what is the cross section of the column? It's I beam. Can you see it's I shape? That means it's not the right column. So I will come here at the property and it change it to be column 50 by 50. And I know that I have column here. I need you to look on the second screen. Everything that I draw here, it's already, know that it's a column. So you put not only the joint, but also draw the frame element of the column itself. Okay. And if you want to look at this, we can extrude, escape. And let me extrude this to be, yeah. So here, can you see what happened here? He has the column and actually put a hinge underneath this column. So he did everything. He drew the column, he made the extrude, he put boundary condition. So it was very easy. So let's do this one more time. I know also there's a column here, there. And I know there's two columns, the edges. Right now, I'm done with all the columns that has cross section 50 by 50. I only have another 4 columns on the corners that are 25 by 70 centimeters. So I draw all the columns in my project. So, yep, here we go. So we can draw the walls next. Actually, the walls also, you can draw it, same thing like what we did with columns. So I need to, can you see what happened here? If I click on the 3D, these will be deactivated, but if I click on 2D, these section will be activated again. That means like, this is how I can draw a wall section. If I put my cursor here, you'll find draw walls. But draw walls only activated if your 2D window is activated. You cannot draw them on the 3D. So if I click on the 3D, they will be deactivated. So you will have to make sure that you are on the 2D screen and you hit draw walls. And I have a wall here. This is my first wall. And another wall here. Just make sure that you, oh, there we go. I will Control Z. So we are good. Then another wall here. Oh, I clicked the wrong point. Okay, I'm done with the edge walls. So let's go do the core. I have a core here. All right. But actually, for this walls, if I click on any one of these walls, it's not the right section. It's called wall 1. So actually what I can do, I can go to select, and I select properties, wall sections, and wall 1. So I select all the sections that are named wall 1, and I'm going to assign shell wall section, assign wall 30 centimeter. Sometimes we do mistakes, sometimes we forgot to change things, but it's good that you catch them and you change them. So all the walls right now are wall 30 centimeters. Okay, so I'm done with the beams, columns, walls. What is next? The slab. Okay, so the slab, you will find the draw rectangular floor. So I can draw here, and I make sure right now that the property is a slab 25 centimeters, and I make a big rectangle here. Okay, right now I draw the slab, but actually the slab has a void at the core location, right? So here you can actually change the drawing to be opening. You can draw an opening as an area, and I know that there is an opening here. And right now, you'll make an opening in a slab. All right. So right now, I'm done with the geometry. So is it much easier? Much easier, right? Okay. So right now, we are done with the geometry. What is the next step? Assign the loads. Because if I run it, it only have the dead load embedded in it, but it doesn't have the flooring. It doesn't have the live load. So I click on the slab, and then I will assign. You will find also shell loads uniform, and it asks, is that dead? No, I'm going to put some live load, and the value of this live load 1.92 Newton. Actually, it should be kilonewton. So how about if we make it 1920 Newton per meter square, and it's in the gravity. Okay. If you want to change the units, you can come here and make consistent units, and it change this to kilonewton. So you click on the slab, assign. How about if we save before we lose it? I saved my model just in case anything happened. So I have my geometry. Oh. Wow. It doesn't want to save. Let's save it on the desktop right now. That's the problem, is working on network. Users. Okay, let's save. Oh no. Device attached to the system is not. Wow. Anyway, everything that we did is right. All the problems that we are facing is because the software is not on the system, or is not on this computer. It's on a virtual machine. And when you run it or you save it, you will find some difficulty. But if you have this software on your machine, you will not have any difficulty saving the file or anything. I did this model on my laptop and worked Yeah, I believe so. But it will be only valid for 1 month. Yeah, maybe you'll use the one on Citrix for like few weeks, like 2 or 3 weeks. Okay, so I will assign the loads, assign shell loads uniform, and I make sure that I have my loads live 1.92. Okay, so I put the live load, I click one more time, assign shell load uniform and flooring, and I will make 1 kilonewton. Oh, it's kilonewton per millimeter square. This is completely different. So let's check the units one more time. Consistent, and this units got it changed when we save the file. So we make sure that the units are okay. Length is meter. Force is kilonewton, and I say okay. Let's go back to assign shell loads uniform, and I will go reassign the live load. And actually what I have here, when I assign live load one more time, it doesn't add, because here I'm saying replace the existing load. So I'm going to replace the existing load with 1.92 kilonewton per meter squared, and then I will hit apply. And then I will click one more time and make this flooring 1 kilonewton per meter square, and then I make sure it's replace existing load, and I hit OK. So right now my loads are defined. So the next thing that we need to define is the meshing, right? We need to divide this into 0.5 by 0.5. ETABS is very good at auto meshing, so you don't have to divide. Once we run the model, or actually we can define this before we run the model, you can go to analyze and do auto mesh settings and ask the software to divide this mesh to 1.25 by 1.25. Then you will say okay. Then you will be able to run your model. Actually, I don't know if I run this model is going to explode or not, but let's give it a try. Yeah, here it doesn't want to run the model. Okay, I'm going to cut this video and add the results from the one model that I run, okay? But I'm going to continue. This is actually the 2D. What if I want to make this a 10-story building? How can I do this? So if I want to make this as a 10-story building, so what you will do is, actually it looks like it's running. We'll make like SAP 2000. It says analyzing and it's a 0%. So we need to stop this. Oh, or it might take less time. So that ideal for this software not to point out. It should be okay. Let me tell you guys. So when you work for a design firm, we do 2D models and 3D models. We only need 3D models for buildings to do measure load analysis. You want to do wind and seismic analysis, or seismic analysis and seismic design. So that's why we need the whole building. But if you want to design the beams, the slabs, you only are enough to do 2D model. And for the 2D model, we need very fine mesh. We need it to be 0.5 by 0.5 at least, so that you can get accurate bending moments on the slabs and accurate bending moments on the beams. Okay, so you need to divide it into very small. But if you are going to design for seismic and wind, I don't care about the mesh size, because the mesh size I already used it to design that slab. But what I care about, I need the weight of the story. So that's when you push a building, what you care about, you don't care about how the meshing is very good at the slab level, but what you care about is that your floor is well attached to the columns and the walls and has the weight is well defined, because when we push the building with the weight load, the weight of the story pushes the story to make the floor. So that's what we make sure about. So in design companies, we make 2D models to analyze the slabs and beams, and we make 3D models that has very big mesh, maybe 2 meters or 3 meters, very, very big, because I don't care. It's because if you make it very fine, your model will be very heavy, because if you have a 60-story and each story has a mesh 0.5 by 0.5, your model will be exploded. That's why we increase the meshes so that the model can run fast. If we are working with 3D models, because what is ETABS and SAP do? They idealize the building. So, for example, this is your multi-story building. 1, 2, 3, 4, 5, whatever stories that you have. So SAP 2000 idealized this story and convert it to a mass. And put this mass here at this elevation. And this mass here at this elevation. This mass here at this elevation. All these masses. And actually count for all the stiffnesses of the columns at this story. They are invariable. So they put K equivalent stiffness and do multi-degree of freedom analysis. Like when you push, there's an earthquake happen at the base, all these masses will move and make them evolve. So that's what I care about. I don't care how does the meshes look like inside you, because I don't care about the bending moment at this stage. I only care about the normal force and the bending moment and the shear force on the columns and the shear wall. So that's why we build a 3D model to design the columns and shear walls, and build a 2D model to design the beams and slabs. Okay. Yeah. All right. So let's make this 3D. Oh, it's run the analysis. Can you see the mesh right now? It's very big. And here it's 1.2. You can click on any point so that you can know the deformation. And same thing, you will be able, if you want to show the bending moment on frames, so you can go to display forces on frames, or you can click on this and you can show M33 and you will hit apply. To the dead load. Right, M33. How about atomic life? Let's remove the extrude. Okay. Here's the bending moments. How it looks like. So you can actually come here and see how it looks like. And actually you can show them on the 2D. You can make this as a plan. Story 1, you make story 1 and say, okay. You can see how's the bending moment on the beams look like at each one of these things. And you can show the moment on the slabs. Apply. Here's how it look like. And as you can see, the mesh is not exactly rectangular. See, like this, like lifting and the meshes, it affects the result, but not that very bad effect. It's better that you have your mesh consistent and in better shape, but it doesn't affect that much. Like if you convert this with what we did in SAP 2000, it will be almost the same. But actually here it's much better because you can see the boundaries of the column and you can read what is exactly the moment at the boundary. Like, as we explained last time, that there's a concentration of the stress at the column, so you need to calculate the moment at the edge of the column or at d/2 from the column. Okay, so this is for the bending moments and M11. If you want to show bending moments, M22, you will say apply. Okay, and then you can see M22 in a y direction. Okay, I need to ask you one technical question. So let's say apply. Okay. All right. So you guys know that there's column here and wall here, column, right? So the column is like a hinge, right? Like support. And the wall also is like a hinge because it makes supports like this. So you can see the moment. It's going positive, negative at the column, positive, negative, positive, negative at the column, and I do this. But if this column hinge and there is no something from here, the moment's supposed to be near zero, right? Why is not zero? There's some moment. There is some stiffness contribution coming from the column that is supporting, because in the previous when we did our 2D model, we represented all the column as hinges, right? But ETABS represented the column with actual column. We put actually a column here and a column here. Right now, this is not vertically hinged and it's not vertically fixed. So it is, you cannot represent, if there's a column, you cannot represent it like this, and you cannot represent it like this. Like either a hinge or either a fixed. It's something in between. Like, let's see. So you have a K here. And it depends on the column. Actually, if you have a different column, you'll have different column. Based on the stiffness of the column and how the stiffness of the column absorbs moment from it. If you added a very, very strong column, this will be built like a fixation. Like if you have a wall, very big wall, it will be like a fixation. This will be like a fixation. And if it's a very tiny column that is 20 centimeters by 20 centimeters, the moment will be almost zero. That's why the codes ask that when you calculate the moment at this stage, you release the moment and make it equal to zero, and you make the moment will be like this, and you add also another negative moment on the side. So you design for positive and negative, okay? Because there is some uncertainty here about what's the short. So that's why the design is completely different from the analysis. When we do design, we do add factor of safeties and we add things that might not logical from a structure analysis, but it's logical from standards and safety. So this will be the actual moment, but we add some negative moment, just like be cautious that there's some negative moment that will be sustained. All right, so let's unlock this model or save this model as 3D. Okay, let's make it slab 3D. Okay. So if you want to show the 3D view one more time, so set 3D view. And what I'm going to do, I'm going to make XZ view. And this is the entire model, the columns, walls, slabs, beams, and everything. If I look at the 3D, I selected everything. And I'm going to edit, replicate, and you will find replicate linear, radial, mirror, and you will find the story. And I will, right now I didn't define the story, so I only have a story one. What I have to do right now, I need to go to the grids and add and modify grids and add more stories. Quick add stories 2, 3, 4, 5, 6, 7, up to 10. And you can modify actually the height of each story. I can make story 1 like 4 meters and a story 2, 5 meters. You can adjust the story's height. And also one of the good things that is, you can make one story master. Like I can say that story 1 is the master story and all the other stories are not master stories. And I'll tell you what is the importance of having a master story. Master story means that all the other stories can be similar to one master story. Like, let me make this as a master story. And this is no. And what I'm going to say that this story is similar to story 1, and this story is similar to story 2. This one will be similar to story 5, similar to story 5. So the importance of master story that anything that you change in the master story will be changed on the other stories that are similar. If you added load, you change the cross section of columns, cross sections of walls, so it saves lots of time. You have typical story, and you make all the other stories similar to it. Okay, so what I'm going to say, I'm going to say okay, and here I'm in a story number 10. So if I go up one more, I will be in the base, and this is story number 1. Okay, I will select my structure one more time. I select all these elements, and I'm going to edit, replicate, story, and I will ask to do all this story and all these stories. And I'm going to apply. Look, I didn't apply yet, and it shows you how it will look like. And I will say apply. Will take a minute, and you will have your 3D story like this, and you can actually show the extruded view. And this is your 3D building. I only need this 3D building for wind and earthquake analysis. I don't need it to design for dead load, live load, flooring. I can do it in 2D. But actually, the 2D model gives you the reaction at each column so that you can know what is the column size that you need to use initially for the 3D model. Okay, so is it much easier from SAP 2000? Okay. All right, so that's everything for today, and see you guys. And actually, next time or in the announcement, I'm going to give more information about the project, because you will need to build the ETAB model for the project. Because some of you will have a midterm for a temper class on the last week of October. Yeah, so I'm going to make it in the first week of November. So, is that good for everyone? Yeah. Okay. I will be good.
One of the things, the homework that you gave us